I realized that I was out of pages on my thing.
Are we in a different spot?
Hello, hello. Working on everybody coming in from lunch. Hang on just a minute. Sure, go real quick. Sorry, I'm waiting on everybody to get in from lunch.
Are we in a different spot?
Huh?
Are we in a different spot?
No, my computer's turned facing a different wall. Usually I'm facing the front, and so I just haven't turned around yet because they haven't come in yet. Yeah, come on in. Hello. Is everybody else here, or where is everybody? I don't know. All righty, well, it looks like we've only got 2 here, so we'll go ahead and get started and then see if the others come in. All righty, so the first thing we need to do is go ahead and check homework. So let's go ahead and open up, and y'all are gonna have to help me remember, I left my sheet at home. Let's see, let me share my screen and pull up the pages. All righty. There we go. Have you seen the other girls today?
No, I just told Alexis's sister, and she said, she asked me if they were here, and I said no.
Oh, okay, does she usually just come for this class?
Yeah.
Okay. Okay. Well, maybe they'll get here in just a little bit. So we'll go ahead and start checking our homework. Let's see. Okay, so looks like we've gone through that. So we've worked with writing expressions with one variable, and then we started working with solving equations with one variable. And so what was our homework?
It was just like keep doing
the packet. Okay, cool. And so we had, that's right, because we had gotten to, we're working on equations with one variable, and then continuing to work with the packet. I will be emailing y'all's test to y'all this afternoon. And so I will send that to y'all this afternoon. So that will be due on Monday. Same with your packet. If it's easier just to take pictures and email, that's fine. You can upload it, you can text it, whatever you want to do. Okay. So what we'll do is we'll just go ahead and start on lesson 20. That's in our textbook, page 43. Okay, so when we left off on Monday, we had started working on translating our equations. What we were doing is we have our phrases that we're turning into mathematical expressions, okay? And so we've looked at we've already looked at doing this, but earlier we were just putting them into expressions. Now we're putting them into equations. we've added the equal sign to it. And so we've learned that is and equals, was, were, yields, gives, all those are going to be indications that we have an equality. So we're going to have something on one side is equal to something on the other side. Okay. And then we're going to start working with solving for a variable that we have in the problem by using our properties of equality to be able to solve. All right, so we will start. It looks like we got halfway through our part of classwork where we were translating, so we'll just pick up there. And we have a number increased by 7 gives 18. Okay, so here are our key things. Number, we know that's where we put our variable x. Increased by, what is increased by? What operation are we going to have? Hey, come on in. We are just getting started. We're on the classwork, lesson 20, page 43. So what operation does increased by tell us, or what does that increase, what does that indicate to us? If something increases and it gets bigger, is that going to be addition, subtraction, multiplication, or division? Any guesses? That's going to be addition. Okay, so we're going to be adding x plus 7, and then our word gives is our key, that that's going to be equals 18. We'll get ready in. Okay. So you're just looking at this one that says a number increased by 7 gives 18. So we've identified x to be our value for our number. Increased by is plus 7. Gives is equals 18. So x plus 7 equals 18. Now, if I knew, we're not having to solve it. We're just translating right now. Okay, never mind. I was jumping ahead. All right, let's look at the next one. 6 decreased by a number is 2. Obviously, we have 6 decreased by a number. Decreased by is going to be what? Decreased means made smaller. Subtraction, good. So we're going to need to subtract by a number. That's where we plug in x. And then we have the word is, and is tells us equals 2. Now, so if 6 is decreased by a number, we know that 6 comes first. So 6 minus x equals 2 is our equation. And then the last one, a number, we know that's going to be x, multiplied by, that one's pretty straightforward. We don't have to guess right there. Multiplied by 2 equals 16. Okay, so we're going to go ahead and say 2x, because remember we talked about how I can write the coefficient and the variable right next to each other, and that indicates that I'm going to be multiplying. When I write them down, I put my coefficient in front of my variable. So 2x equals 16. Okay. All righty. The next part says solve by combining like terms. Check your work by substituting into the original equation. So the first thing that we're going to do is we need to look to see what terms need to be combined. All right, so I have x plus x equals 8. Remember, I think we've talked about the fact that if I have a variable with no number in front of it, I understand that variable to be 1. Okay, so if I have a variable by itself and I'm adding, I can put that 1 in front of it to help me remember that I'm going to add 1 plus 1, and that's going to give me 2x. Okay, so 1x plus 2x. Basically, it would be like if I had apples and I said 1 apple and 2 apples. Okay, if I had, so it's just 1x and then another x, so when I put them together, it's 2 x's. Okay, so 2x equals 8. Now, what operation is happening with 2 and x? What did I say when I have a number and a variable next to each other? What operation is that? Multiplication. How do I undo multiplication? What is the opposite? Division. Good. So I'm going to divide because I want x to be by himself. Okay, so I want to divide 2 from x. So I'm going to divide by 2, but whatever I do on the left-hand side, I have to do on the right-hand side to keep it balanced. Okay, so now I have 2x divided by 2 equals 8 divided by 2. All right, so notice when I do 2x divided by 2, 2 divided by 2 is 1. So all I'm left with on the left-hand side is x, and what is 8 divided by 2? 4. So x equals 4. So we've solved for x, and then it tells us to check it by plugging it back in. Okay, so if I'm going to take those ones away now, because now we know what x is. So I can plug in 4 and say 4 plus 4 equals 8. And that is a true statement because 4 plus 4 does equal 8. Okay, so I can always go back and check by plugging in the value that I have solved for and make sure it all works out. So let's look at the next one. I have 2 plus 3 plus x equals 9. What are my like terms here? What are my terms that are the same type of thing?
2 and 3.
2 and 3. I've got the numbers 2 and 3. 2 and 3 are what we call constants. Numbers are constants because they never change. Whereas a variable, it could change. It might be 5 in this problem, and in the next problem, it's a 2. Okay, so when I have a variable, I don't know what that is. So just like in the first one, we combined variable with variable. Because they were the same variable, I could combine them. So here I'm adding 2 and 3. So 2 plus 3 is 5 plus x equals 9. Now, if I knew what x was, if I knew what that number was, I would do 5 plus that number equals 9. But I don't know what 5 is, so I'm going to have to use the opposite operation to solve, okay? So if I knew what it was and I would add, what's the opposite of addition? Subtraction. So now I'm going to subtract. And so what I'm going to do is I'm going to subtract 5 from each side. 5 is positive to begin with, so I'm going to subtract it. And so 5 minus 5 is 0, so those cancel out. So all I have left on my left-hand side is x equals, and then 9 minus 5 is 4. We got 4 again for our answer. So again, they said check it by plugging everything in. So we said 2 plus 3 is 5, and 5 plus 4 equals 9. So that checks. We know we got that one correct. Now let's look at the last one. I have 2x plus 4 plus 1. So 2x and x are like terms that I can combine. And 4 and 1 are like terms that I can combine. Okay? So what is 2x plus x? What did we say we understand the number in front of just the plain old x to be? 1. So what's 2 plus 1?
3.
3. So 2x plus x is 3x. Plus, what's 4 plus 1? 5. Equals 17. Okay, now this one's a little more tricky because I've got 3x plus 5 equals 17. So think about order of operations tells me that if I knew what x was, I would have a certain order. to do this. And the first thing I would do is I would multiply 3 times x, or whatever that number is, right? So that would be the first thing I would do. The next thing I would do is to add 5. Okay? So to solve for x, I have to do the reverse order and do the opposite operations. So we said the first thing would be to multiply and then add. So now I've got to do them in reverse order, opposite. So what is the opposite of addition? Subtraction. What is the opposite of multiplication? Division. So to solve this problem, I'm going to need to subtract first and then divide. So what I do is I subtract what is currently being added. What is being added in 3x plus 5? I've got plus 5, right? So that's the addition part of it. So that means I'm going to start by taking away 5, but remember I have to do it on both sides to make it equal. So now 3x plus 5 minus 5. 5 minus 5 is 0, so that cancels out. So all I have left on the left-hand side is 3x equals, and then what's 17 minus 5? 12. Now I have 3x equals 12. So we said that I would subtract first, then I would need to divide. I'm going to divide what is being multiplied. Right now it is 3 times x. So I'm going to need to divide by 3, divide by 3. So what does x equal?
4 again.
4 again. So it ended up equaling 4 for all of these. All right, now we're going to plug it in and see if we've got the right answer. So here I would plug in, so I've got 2 times 4 plus 4 plus 4 plus 1 equals 17. All right, what is 2 times 4? 2
8.
times 4 is 8, plus 4 plus 4 plus 1 equals 17. So what's 8 plus 4? 12 plus 4 plus 1 equals 17. What's 12 plus 4? 16 plus 1 equals 17. And that makes a true statement. So we know that we solved for the correct value. Okay, so you can always check to make sure once you get down and say, hey, my answer x equals whatever, I can plug it back into my original problem and make sure that it's a true statement. Okay, make sure that it ends up working out right. All righty, so let's look at all right. Go ahead and work activities 2 on page 3. Go ahead and write statements for these equations. If you need to look back in your book to figure out what some of the terms mean, what is the addition, subtraction, let's see what page that was. What page that was on. That is going to be on page, my page number in there. It's 41. So page 41 has all of our terms for addition, subtraction, multiplication, and division. So if you want to review those first. So that has our operation words, and then our words for equals is on the page we're working on. So if you have any questions, be sure to let me know. We're going ahead and work in activities 2 on page 43. You there, Hunter? I've been having internet trouble today, so every once in a while I've had trouble with it dropping out. So if it drops out and you get kicked out completely, just know that I'm working to restart it, and just go ahead and log back in, and I'll get you in as soon as I can.
Okay.
For some reason, it won't let me share my screen.
So I didn't miss any homework when I dropped out early the other day.
No.
Okay.
No, we just finished working on our packet and got
Greatest common factor is really hard.
huh?
Greatest common factor is really hard.
Yeah, you just list out those factors and group them. So just keep, working through that. Just remember, list your prime factors. Let's see, I'm gonna try to close out of this Zoom and then log back in and see if it'll work. Pre-algebra Thursday. There we go. Okay, let's go ahead and get ready and look at these. So the total of a number and 45 is 56. So how would we write that? What would y'all come up with?
X plus 45 equals 56.
Very good. X plus 45 equals 56. How about 9 fewer than a number equals 5? This one's one of those tricky ones because it says fewer than a number. So what comes first? X. What's our operation?
Subtraction.
Subtraction, good. Minus. X minus 9 equals 5. Good. A number times 8 yields 32. So if I'm going to multiply 8 in my number, I go ahead and list it as 8x equals 32. I could also do it as, I could put it in parentheses if I wanted to, but remember we just talked about the main thing I don't want to do is use my x as a time sign when I'm dealing with the variable x. The sum of 29 and a number is 47. So 29, what's my operation? Addition. 29 plus x equals 47. The quotient of a number and 9 yields 6. So what does quotient tell me?
Division.
Division, good. So the quotient of a number and 6. One of the things to notice is whenever I'm doing division, they're always going to give me my first bit of it. My first piece of information is going to be my big number. Okay, the one that I'm dividing into the dividend. Okay, so I know I'm going to have x divided by 9 yields is equals 6. Okay, so I could list it as x divided by 9 using my division sign like that. I could also use a fraction, x divided by 9 equals 6. So I could either list it with my division sign or I can use a fraction.
X equals 54, right? In that one?
It says the quotient of a number and 9. So what it's saying is when it says a number and 9, this is where I have a number divided by 9 equals 6.
I got that. I was just trying, like, X is 54.
Oh, yeah. So you would, yeah. So basically, you know, whatever 9 times 6 is 54. So it's 54 divided by 9 is 6. Good. So X is equal to 54. Yes. All right. 7 less than a number is 8. So when I have less than a number, what's going to come first? X, our number comes first. Less than is subtraction, so x minus 7 equals 18. A number increased by a factor of. What operation is that one? No, addition is increased by, but which one? Multiplication. So these are tricky. So increased by is addition. If it just said increased by, that would be addition. But where it says increased by a factor of, remember factors are numbers that multiply together to make another number. So that's our big key word right there is factor, is the word factor. So a number increased by a factor of 3. So that means I've got a number times 3. So we could write that as 3x gives or equals 21. 43 more than a number is 77. So I have 43. What tells me more than? Addition. So plus x equals 77. And then the last one, a number less than 83 equals 42. So my number less than 83, so what's going to come first? 83 comes first. Good. 83 minus x equals 42. Okay, good job. Let's go ahead and look at activities 3 on the next page. It says to solve by combining like terms and follow the rules for signed numbers and check your work. Okay, so let's go work through these. X plus 5 plus 3 equals 13. Go ahead and work that on your own, and then we're going to talk about it. Look to see what numbers or variables can be combined. So what are you going to combine first? And then how would you solve that? So let's look at this together. The first thing I need to do is combine like terms. What are my like terms in this one? 5 and 3. So I've got two numbers that can be combined. And what is 5 plus 3? 8. So I have x plus 8 equals 13. So basically this is saying what plus 8 equals 13. So remember that when I want to solve for x, I look and see, I look at my problem first and say, if I knew what x was, how would I solve my problem? So let's pretend like I knew what number x was. What would I do to solve? How could I solve that problem if I knew what x was? I would just add, right? So I would add to be able to solve the problem. So to be able to solve it when it's a variable, I have to do the opposite operation. What is the opposite of addition? Subtraction. So that tells me I'm going to need to subtract something to be able to solve, okay? And the way I decide what that something is that I'm going to subtract is going to be what is being added. So what is being added to x on the left-hand side? 8. So that means I have to take away 8 because I want it to move to the other side, because my whole purpose, my whole goal in solving for x is to isolate x. I need x to be left all by himself on the left-hand side, okay? So I want to try to get rid of everything else that's over there. And so the way that I move things is I have to use those properties of equality, because I've got to keep my equation balanced the whole time. So I can't add anything to one side without adding it to the other side, or subtracting one thing without subtracting from the other side. So over here, I need to get 8 away from x, because I need x to be all by himself. So if I have plus 8 and minus 8, that's going to be 0, right? So I'm left with x equals, and what is 13 minus 8? 5. So x equals 5. Okay, so then I could plug it in over here and say 5 plus 3 equals 13. Well, 5 plus 5 is 10. 10 plus 3 is 13. Okay, let's look at the next one. Go ahead and work the next one. This one's a little more challenging. So we've got 2 things that we have to do, or actually 3 things, because we've got to start by combining like terms. All right, so when we start combining like terms, what are the terms that we're combining?
4 and 8.
Okay, we can combine 4 and 8. And what else? The 2 x's. X plus x equals 2x. So we have 2x plus, what is 4 plus 8? 12 equals 26. All right, I'm going to bring that out over here. So I've got enough room to work it. 2x plus 12 equals 26. So let's look at that for a minute. If I knew what x was, and I use the order of operations, I can look and I can tell that I would multiply first, then I would add to be able to solve this, okay? So I would multiply, then add. So remember, to be able to undo my problem or to solve, I've got to do that in reverse order. So that means I have to flip-flop and I have to use opposite operations. So I'm going to flip-flop. So that means I would do plus first, but what is the opposite of addition? Subtraction. So I need to subtract. Then What's the opposite of multiplication? Division. So I'm going to need to subtract, then divide. So I go back to my equation and I look at it and I say, okay, well, if I've got to subtract, my whole purpose of subtracting is to make something equal 0 because I'm trying to move it. So I'm going to subtract what is currently being added. 12 is being added in my original problem, so I'm going to subtract it now. So you there? Sorry.
Yeah.
Crazy internet. I need to plug in my iPad, I guess, in just a minute. I may have to set up a Wi-Fi through my phone. Let's see if it'll let me share again. Okay. So we said that we would have to undo 2x, being that 2 is being multiplied by x. So to undo that, we divide. So 2 divided by 2 cancels because 2 divided by 2 is 1. So now I have x by himself, and 14 divided by 2 is 7. So I'm going to plug in 7 to check it. So I would have 7 plus 7 plus 4 plus 8. 7 plus 7 is 14. 14 plus 12 is 26. So we know that is correct. Okay, let's look at the next one. Go ahead and combine your like terms. So 2x plus x is going to be
3x.
3x. And 7 minus 2 is going to be what? 5. So we have 3x plus 5 equals 17. If I was going to solve this problem, if I knew what x was, what order would I do this problem in? What would I do first? What operation is happening right here? Multiplication. And then what is this right here? Addition. According to the order of operations using PEMDAS, what comes first? Multiplication or addition?
Multiplication.
Multiplication. So if we knew what this was, I would multiply first and then I would add. So to be able to undo it, I've got to reverse my order and I've got to do inverse operations. So that means I've got to reverse my order here. So what is the opposite of addition? Subtraction. What is the opposite of multiplication? Division. So I know these are the two operations I'm going to use to undo this problem. Okay. I know I'm going to subtract what is being added and then divide what is being multiplied. So I'm going to change colors so then that way I won't run into all that red. 3x plus 5 equals 17. So we said the first thing we would do is subtract. What am I going to subtract? What is being added? 5. So that's where I'm going to start. I'm going to subtract 5 from each side. So my 5's cancel because a positive 5 minus 5 is 0. So I'm left with 3x on the left-hand side. And then 17 minus 5 is 12. So now I have 3x equals 12. Remember, my goal is to get x by himself. I need to isolate x to tell what it's equal to. So currently, 3x tells me it is being multiplied. How do I undo multiplication? Divide. So I draw my fraction line to divide, and I divide by 3, divide by 3. So 3 divided by 3 is 1, so those cancel. So x is equal to 4. Good. Okay, let's look at the next one. Now we have to be real careful on this one, combining our terms. What is 3x plus 2x?
5x.
Good, 5x, because 3 plus 2 is 5, and I just keep my x. Now look at this. I have negative 8 plus 3. What is negative 8 plus 3? Good, negative 5. I take the sign of the larger and find the difference of my number. So now I have 5x minus 5 equals 30. Okay, so let's go through the process of thinking about if I knew what x was, what would I do to solve it? Order of operations tells me I would do what first in this problem? Multiplication, then I would multiply, then subtract. Yeah, this one's a little bit different, so I'm going to go ahead and make myself a note. I would multiply, and then I would subtract. So I'm going to do them in reverse order, and I'm going to use inverse operations. So that means I'm going to add, then divide. So what am I going to add? So we have 5x minus 5 equals 30. So I'm going to add what is being subtracted. What's being subtracted? 5. So that means I'm going to add it now. So if I add on the left-hand side, I have to add on the right-hand side. So a negative 5 plus 5, those cancel out. So what's left on the left-hand side?
30 plus 5x.
Okay, on the left-hand side, I have 5x, and on the right-hand side, I have 30 plus 5. So what's 30 plus 5? 35. So now I have 5x is equal to 35. All right, I have 5 times x. How am I going to undo that?
Division.
Divide by 5, divide by 5. So what does x equal?
7.
7. Very good. Okay, again, I can plug in 7 and check. So this right here would be 3 times 7 plus 2 times 7 minus 8 plus 3. So let's take a look at that. 3 times 7 is
21.
21 plus 2 times 7 is
14.
14. So now I have 21 plus 14 minus 8 plus 3 equals 30. So what is 21 plus 14?
35.
35, good. So that's 35 minus 8 plus 3 equals 30. What's 35 minus 8? Let me plug in my 35 minus 8 is going to be 27. Good. And so then let's see. Just plug it. There you go. That'll go away. Okay, so we said 35 minus 8 is 27, and 27 plus 3 is 30. Okay? All right. I want you to try to do the next one. I want you to work on that one, and we'll look at it together. Oh, there's the bell for our break, so we're going to take a 5-minute break. When we come back, we'll work on this one. Okay. So let's go ahead and look at this one. Go ahead and work on first, combine your like terms and see what your order of operations would tell you to do to solve it. Think about your opposite inverse operations to undo the problem to be able to solve for x. Okay, so let's go ahead and look at our combined terms. So 4x minus 2x is 2x. And then I have a positive 10 minus 5 is going to be plus 5 minus 3 equals 22. So now I'm going to combine that 5 and 3. So what is that going to be? Positive 5 minus 3? 2. So now I have 2x plus 2 equals 22. Okay, so now we've got to think about our order of operations. So how, if I knew what x was, what would be my first thing I would do? I would multiply, then add. So I would multiply, then add. So to undo my problem, what am I going to do? Subtract, then divide. Okay, so I've got 2x plus 2 equals 22. So my first step is going to be subtract 2. Oh, all right, there we go. Come on. From both sides. And so now I have those cancel out. So I have 2x is equal to 20. So my next step, divide by 2, divide by 2. So x equals 10. How's everybody doing with this? Are you getting more comfortable with it? Feeling okay? Feeling good with how to know what order to undo your problem? And then we have the last one, 4x plus 3x minus x. 4x plus 3x is 7x, and 7x minus x is 6x. Negative 4 minus 3. Let's think about that for a minute. Negative 4 minus 3. Remember, when I have a negative 4 minus 3, I can change that to adding the opposite, so I'd have negative 4 plus a negative 3. So what is negative 4 plus a negative 3? So remember, think about your number line. Negative what? Negative 7. Good. A negative plus a negative is going to give me a greater negative. Okay. So if I have a negative plus a negative, that gives me a larger negative. So now I've got negative 7 plus 2. What's that going to be?
-5.
Good. Negative 7 plus 2 is a negative 5. So I have 6x minus 5 equals 49. Come over here. 6x minus 5 equals 49. If I knew what x was, what would be my order to solve? I would multiply, then subtract. So now I've got to flip-flop and give my opposite operation. So what am I going to do first to solve this? I need to add, then divide. Okay, I'm going to circle those so I remember that that's what I'm working with. All righty, so what am I going to add? 5. 5 is being subtracted, so that's where I start. I'm going to add both sides. So my minus 5 plus 5 cancels, so I have 6x is equal to 49 plus 5 is 54. My next step is to divide. What am I doing? I need to divide by 6, divide by 6. So x equals 9, because 6 times 9 is 54. Okay? So when I'm working on equations, when I'm working on solving equations, I always want to start out by looking to see, is there anything, are there any like terms that I can start off by combining? I want to start by simplifying what I've got. And a lot of times that's going to be combining like terms. Once I've combined my like terms, I look to see what operations I have involved in my problem and how I can undo it to solve. Okay? All righty. So let's go ahead and move to lesson 21. So that is going to be on page 47. This is dealing with word problems. All right, and so it says solving word problems is easy if you remember 4 steps that spell out word. Okay, so they put an acronym in here for us, the word word. Okay, and W stands for what are you asked to find. And so your W, your what, this is going to be your unknown, and we represent that using a variable. So in a problem, whatever it's asking me to solve, I let it be represented by the variable, okay? O stands for organize the information in the word problem by translating the words and phrases into mathematical expressions. watch for extra information in the problem that is not necessary for solving the problem. You will not necessarily use every number mentioned in the problem. So you've got to read the problem, figure out what's related, what information you need to use to be able to set up a problem to be able to solve for your variable. R stands for rearrange. Rearrange the equation by isolating the variable on one side of the equal sign and combining the like terms. Typically, I like to go ahead and set everything up where I have my variable on the left-hand side, because the proper way for reporting your answer is you always want to have variable equals whatever. And so I always like to just go ahead and set it up to where my variable's on the left-hand side and I move all my other numbers to the right-hand side. And then that way it kind of keeps it in order. And then D stands for does the answer make sense? If you start with 24 cookies in a jar and 4 people eat 12 cookies for dessert, it does not make sense to say there's 32 cookies remaining in the jar. So we always want to look at our answer and think, does this make sense? Okay, like if you were doing a question and it wanted to know the weight of a mouse, I don't know, and it came up to be like 300 pounds. Okay, you'd be like, oh my, something's wrong. Either that or you got a giant rat on your hands. No, I'm just kidding. No, you've got to look at it and say, hey, is this really reasonable? Does this make sense? Could this be a legitimate answer? And a lot of times if you look at something that doesn't look right, then there's probably a mistake somewhere in there. And so that's why, especially with solving problems and especially with word problems, you really want to be sure to write things out. You want to write things out and show your work, because if you get to the end and you get to the answer and it doesn't make sense, when you look back, you're not going to be sure where you made your mistakes, so you don't know what to fix. Okay, so I always recommend showing your work as you're working through a problem. Show every single step, so then that way if you look back and you go, oh, that was where my little mistake was, and you fix that, and then you fix your answer instead of having to start all over at the beginning and totally reworking the problem. Okay, so let's go ahead and take a look at this. So we've talked about kind of our acronym word. So we're going to look at the classwork and we're going to fill this out. So first of all, we'll read the problem. And it says, last Saturday, Billy sold 37 energy drinks for $2 each and 112 cans of soda for $1 each. How much money did the concession stand bring in on Saturday from the sales of energy drinks and soda? So let's look at our W, okay? What are we asked to find? What do we need to find in this problem? Okay. How much money from drinks and soda? Okay. Because if I gave a number and I forgot my dollar sign, you know, so that's something we've got to think about. Hey, I'm going to have a dollar sign. Now it says O for organize the information. So let's think about, how can we organize this information that we have? What do we know from the problem? How many energy drinks were there? 37. How much did each cost? How can I figure out what the total was for energy drinks? 37 times 2. So I know that I'm going to do 37 times 2. And then how many sodas were sold? 112. And how much did they cost each? So how much money was brought in just on sodas? $120 on sodas. Okay, so we know that we've got 37 times 2. So what is 37 times 2? Let's think about 2 times 7 is 14. Carry our 1. 2 times 3 is 6 plus 1 is 7. So $74 on energy drinks, 112 on soda. So what's our plan for figuring out our total? What would we do with 74 and 112? We're going to add them together. So 74 plus 112. All right, so R says rearrange. I guess I messed up on here because I didn't set it up with the variable. And so I guess we'll have, what we'll do is we'll have 74 plus 112 equals X. So that means X is equal to 74 plus 112. So now, what's our total? What is 112 plus 74?
186.
186. And so the D part, does that make sense? So when we think about, okay, I know that 112 is about, if we rounded to 100, that would be 174 would round to 75, so we'd be at 175. So 186 is pretty close to that. Okay, so we know that we're in the hundreds. If we came up with an answer that said just $86, we know we'd be off. If we came up with an answer that was $1,860, we knew we would be off. Okay, so does it make sense? It does. Okay, so kind of working through word problems like that, thinking about, okay, what do I need to find out? What information is going to be helpful to me? And then how am I going to organize that information to be able to solve it? All right, let's look at activities 2. It says, at Billy's concession stand, soccer players may choose from a pouch of fruit punch, a bottle of sports drink, or a bottle of water for their beverage. Fruit punch costs 75 cents and water costs an additional 75 cents. If a sports drink costs twice as much as a bottle of water, how much does Billy charge for each sports drink? Oh my goodness, there's all kinds of information here in there. So let's think first about what they've asked us to find out, and that is, how much does he charge for a sports drink? Okay, so does it matter how much he charges for water, really? That's not in our problem, does it matter how much fruit punch is? We're not having to find those totals, but when we look at how these things are related, okay, so it says fruit punch costs 75 cents and water costs an additional 25 cents. So how much is each water? If fruit punch is 75 cents and water's 25 cents more than the fruit punch, then we know water's $1, okay? And then it says a sports drink costs twice as much as a bottle of water. So that means we have 2 times the bottle of water. So what is 2 times the bottle of water going to be? $2, okay? So kind of breaking through that. So he charges $2 for the sports drinks. Soccer players have the option of purchasing a full season meal plan from Billy's concession stand. The meal plan costs $10 for the 8-week season. Each game, players may choose a hot dog or hamburger along with their choice of fruit punch, water, or sports drink. If a hot dog costs $1 and a hamburger costs $2, and the drinks are priced according to the problem above, how much will each player save if he orders a hamburger and a sports drink in each of the 8 weeks? All right, so let's think about this. We're trying to figure out how much he's going to save by ordering separately than doing the meal plan. Is that right? How much save if he orders a hamburger and sports drink each of the 8 weeks? Okay, so let's think about from problem 1. We knew that fruit punch was 75 cents. We knew that water was $1 and a sports drink is $2. Okay, that was what we figured out in the first problem. Now, what did we learn the total cost of the meal plan is? The meal plan costs $10 for 8 weeks. Okay, that's pretty good. So then, a hot dog is $1 and a hamburger costs $2. So we're wanting to see if you ordered a hamburger and a sports drink for 8 weeks. How much is a hamburger?
$2.
Hamburger's $2. How much is the sports drink?
$2.
$2. So how much are you spending to order a hamburger and a sports drink?
$4.
$4. If you ordered that for 32 weeks, for 8 weeks, how much money are you spending?
$32.
$32. Now we know how much it would be What was the question? What did our problem ask us?
How much will they be saving if they do
How
the
much?
plan?
So if he went ahead and bought the meal plan, how much is he going to spend?
$10.
$10. So how are we going to figure out how much money he saved?
32 minus 10.
32 minus 10, and he saves $22. Okay, so we looked at the information that it gave us. We organized it in a way that we could be able to solve. And then we checked to see if it makes sense.
That is quite a savings. I mean, seriously. If only it was like that for real.
Say that again.
If only it was like that for real. $10 for 8 meals.
I know. Can you even imagine $10 for 8 weeks of eating? That's all. And my thing is how much is good for a hamburger and a drink. I can't even get out of it. I mean, think about when your family goes to McDonald's or, Chick-fil-A or wherever. I mean, it's okay. Billy let teenagers from the church youth group help in the concession stand. The profits are divided evenly among the teens who work. They purchase a case of 48 cans of soft drinks from a warehouse club for $9. If they sell them for $1 per can, how much money would each of the 3 teenagers earn from the sales of the soda? So we're trying to figure out how much they're going to earn, okay? So now that tells us that we've got to figure out how much they earn to be able to divide it among the kids. So how many cans were they able to buy? 48 cans. And how much did they spend on those 48 cans? $9. So how can we figure out how much it costs per can? $9 divided by 48 cans. So that's where we're going to start. So I'm going to put 48 into 9.00. Remember, when I divide, if I have a decimal, I want to go ahead and put that in my answer so I don't forget it. So 48 will not go in 9, so I'll go ahead and put a 0 there, but 48 will go into 90 how many times?
Once.
Just one time, because 48 times 2 is going to be 96, and that's too much. So one time. So 1 times 48 is 48. So now I'm going to subtract 90 minus 48. That's going to be a 10. My 9 becomes an 8, so that's going to be 52. No, 42. 42. And remember when we divide, did y'all ever do DMSCB, does McDonald's sell cheeseburgers? Did you ever learn that with long division? Okay, so for long division, DMSCB, like I said, I learned it as does McDonald's sell cheeseburgers? This stands for divide, multiply, subtract, and this part right here, compare, and then bring down. So we divided 48 into 90. That was our first step. And we found that was 1. Then we multiplied 1 times 48. So that was to multiply. Then we subtracted 90 minus 48. Now this step is to compare. And what that means is I want to make sure that my answer from my subtraction problem is smaller than my number on the outside, that 48. So I've got 42 that is smaller than 48. So that means I'm good to continue going. If I found that my number was larger when I subtracted than my number that I'm dividing by, I know I haven't divided by enough. Okay, so that compare step is important because I want to make sure that this number is smaller than this number. It is, so I'm good to go. So my next step is to bring down. So I bring down my 0. So 42 now became 420. All right, so 48 will go into 420. Well, I know 48 times 10 would be 480, and I know that's, I couldn't do that 10 anyway. So I could try 9. Let's try 9. 9 times 8 is 72. Carry my 7. 9 times 4 is 36 plus 7 is too much. I've got 422, so I know 9 is too much. So I'm going to go back, and we're going to go with 8. 8 times 8 is 64. Put down my 4, carry my 6. 8 times 4 is 32. 32 plus 8 is 40. So now I subtract. That's a 10. My 2 becomes a 1, so I make that 11. No, I don't need to make that 11 because that's a, hold up. That's a 10. So 2 becomes a 1. I don't have to borrow. Okay, so 10 minus 4 is 6. 1 minus 0 is 16. So I compare. My 16 is smaller than 48, so I put a 0 and bring it down. 48 will go into 160. Is that going to be 3 times? 3 times 8 is 24. Put down my 4, carry my 2. 3 times 4 is 12, 13, 14. 144, 10, 6 becomes a 5. So I've got 16. So I can see that, what do I notice here? I'm starting to repeat, aren't I? So I know that I've got 0.18 repeating. So I would just go ahead and round that to about 18 cents a can. Okay? So the cost is about 18 cents a can. How much are they charging for their drinks? When they sell them, how much are they charging? $1. So how much are they making per can? I mean, how much are they making for 48 sodas? They're going to make $48. And we found that really the cost of the cans are only 18 cents. So if they're making $48, but how much did they spend total on those cans, on the total 48 cans? What did we say their total was? No, but how much did they spend total on them? $9. So what, we're going to do 48 minus 9. I took y'all through an exercise that we didn't necessarily have to go through to find our answer, but I just wanted I wanted to work on that long division, and then also I wanted you to see, you know, how much they're making per can. Okay, so 48 minus 9 is going to be what? So $39 is the profit, right? Because this is how much they made. This is what the cost was. To figure out profit, you have to take how much you earned and subtract what you spent. So $39. How many kids were there that were working the thing?
$3. I mean, 3 kids. But.
3.
Okay, it says 3 teenagers. So now I'm going to divide my $39 by the 3 teenagers, and how much do they each make?
$13.
$13. 3 will go into 39 13 times. Okay? There's all kinds of different things that we can look at, especially when you're talking about cost per item. So so you can see that really they're charging $1, but they've only paid 18 cents per can. And so you can see that the profit there, and then they are able to split that and make that money. All righty. Let's see. Let's go ahead and work through our activities, page 48 together. Because I don't want to give you any more homework since you've got a test. I'm going to be emailing you your test, and you've got your packet to finish up. Let's go ahead and review these review absolute values. What does absolute value represent? What does absolute value tell me? Starts with a D. The distance.
The distance between the numbers.
Okay, so the distance from what number on a number line?
0.
Distance from 0, yeah. So look at the first one. I've got negative 32, the absolute value of negative 32 plus the absolute value of negative 17. So remember, when we talk about absolute value, when we talk about distance, distance cannot be negative. Just because I drive south, I don't go negative miles after I've gone north. Just because I've gone one way and then I go back, it's not negative distance. Distance is always positive. So the absolute value of negative 32 is going to be what? 32. I have my plus sign in between the absolute value of negative 17. 17. So now I have 32 plus 17. What is 32 plus 17? 49. Good. What's the absolute value of negative 15? 15 plus the absolute value of 47. 47. So what is 15 plus 47? Close. What's 5 plus 7? That's going to be 12, and I carry my 1. So I have 4 plus 1 plus 1. 62. All right, let's look at the next one. 57. I'm sorry, the absolute value of 57 is 57. I have a minus sign, and what's the absolute value of negative 33? So 57 minus 33 equals 24. All right, the next one looks different. Of the absolute value of 14. What is the absolute value of 14? 14. What's the opposite of 14? Negative 14. Good. Plus, what is the absolute value of negative 6? 6. So now I have negative 14 plus 6. I have a positive and a negative being added together. So what is my rule for when I have a positive and a negative being added together? I take the sign of the larger and then subtract. So which one is larger? 14, and that's negative. So now I'm going to subtract, and what is 14 minus 6? 8. So I end up with negative 8. All right, moving along to the other side. The opposite of the absolute value of 42. What's the absolute value of 42? 42. What is the opposite of that? Negative 42. Minus the absolute value of 16 is 16. I have negative 42 minus 16. I want to change that to negative 42 plus, so I've changed my subtraction to addition. So now that means I've got to take the opposite of 16, so that will be negative 16. So negative 42 plus a negative 16. What do I do when I have the same signs? Keep the sign and add them. So it's going to be negative 58. All right, now we are adding inside our absolute value signs. What is 18 plus 26? 44. So I have the absolute value of 44 plus the absolute value of 27 minus 5. What's 27 minus 5? 22. All right, so they have the absolute value of 44 plus the absolute value of 22. So the absolute value of 44 is 44 plus the absolute value of 22 is 22. So that total is 66. All right, I've got the opposite of the absolute value of 53 minus 24 plus the absolute value of 14 minus 21. So let's take a look at this. The first thing I've got to do is find the absolute value of 53 minus 24. So what is the absolute value? I'm sorry, what is 53 minus 24? Okay, so I'm going to look, and 13 or 3 minus 4 can't do, so 13 minus 4 is 9, and then my 5 reduces to a 4, and 4 minus 2 is 2. So now I have the opposite of the absolute value of 29 plus the absolute value of, what is 14 minus 21? Excuse me. 14 minus 21, huh? 7, good. What kind of 7? Negative. My larger sign, basically, this is the same as positive 14 minus 21. I could flip that around to negative 21 plus 14, okay? But I can see that that negative is with the 21, so that's my larger. So I'm going to have negative 7 in my absolute value. So now I have the opposite of the absolute value 9. It's going to be what? Negative 29 plus the absolute value of -7 is going to be +7. Now, -29 plus 7. What's the sign of my larger? Negative. And then what do I do with my numbers? I subtract. 29 minus 7 is 22. So I have -22. And then the last one. What is 41 plus 16? Okay, so I have the opposite of the absolute value of 57 minus the absolute value of what's 29 minus 17?
12.
12. Good. All right, so now I have the opposite of the absolute value of 57. It's going to be what?
-57.
-57 minus the absolute value of 12 is 12. So I have -57 minus 12. That means I already have a negative and I'm taking more away. So I can rewrite that by changing that to adding the opposite. So -57 plus -12 is going to be what? -69. Okay. How am I feeling with those absolute values? Feeling pretty comfortable with them? Good, 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 good. Divisibility test, greatest common factor, all that good stuff. Solving roots. Let's check our time. 2:10, we've still got just a little bit left. All right, so what is our rule for solving roots? What do we want to do first? Factors. Okay, what is the smallest prime factor of 27? 3. 3 times what is 27? 3 times 9. What am I small? 9. 3, and that's going to be 3 times 3. I'm dealing with a square root, so how many numbers do I need to have in my groupings?
2.
Oh, my board's lagging it. I've got my roots up on my iPad, but it's taking time on the screen. That tells me my internet's having trouble. Come on. There we go. There it is. All righty. So doing square roots tells me I have to have 2 buddies group. So I circle my 2 buddies. They come outside as a whole number. And then I have a guy that's left under the radical. So my answer is 3 times the square root of 3. Square root of 32. What's my smallest prime factor?
2.
2. That's going to be 2 times what? What's half of 32? What's half of 30?
16.
Good, 16, because half of 30 is 15, so half of 30 is 16. So what's the smallest prime factor of 16? 2, and that's 2 times what? 8, and my smallest prime factor of 8?
2.
2, and that's going to be 2 times 4, and 4 is going to be 2 times 2. All right, so find my groups. I've got 1 group, I've got 2 groups. So when those 2 groups come out, what do I do with those 2's? I multiply them. So I've got 2 times 2, and then I have the square root of 2 left under there. So 2 times 2 is 4 times the square root of 2. All right, the square root of 40. What's my smallest prime factor of 40?
2.
2, and that's going to be 2 times
20.
20, smallest prime factor of 20,
2.
and that's going to be 2 times
10.
10, smallest prime factor of 10,
2.
and that's going to be 2 times
5.
5. All right, so I have 2 2's that come outside. So I've got 2, and then I have a 5 and a 2 left under the radical. So what do I do for the final answer? Multiply those together, and 5 times 2 is 10. So my answer is 2 times the square root of 10. Y'all are doing really well with these. All right, 4. And actually, you know what? Let's go ahead and be done with those. Let's go on. Let's just go on and add and subtract. Let's look over here at the 3 times the square root of 11 plus 6 times the square root of 11. What is my rule for adding radicals?
6 plus
just add 6 plus 3 because my radicals are the same. I have the square root of 11 on both of them. So 6 plus 3 is 9 times the square root of 11. Now, I always want to check that square root and make sure it's in simplest form, because I want to make sure, just like you know how when you do fractions, you always want to make sure your fractions are in simplest form. Same thing with radicals. I always want to make sure that's in simplest form. Let's look at the next one for a minute. I just said that I have to have the same radical to add and subtract. I have the square root of 8 minus the square root of 2. Are those the same? They're not the same, are they? Oh, my thing hasn't caught up yet, has it? Come on. Catch up. Oh, my iPad will connect again. Okay. I think my iPad said, you know what? I'm done for the day. I'm tired of thinking. Don't want to do this anymore. I'm not, that's what I'm saying. Maybe I am just a little bit. I think y'all are tired too. I think we're all tired. Come on. So you know what? Y'all just need to take a break and be done. Oh, too bad, so sad. Okay. Only the host can share this meeting. That's funny. So it's telling me I can't share and it's all enough anyway. All right, so what I'm going to do is, it won't let me share. The square root of 8 is different from the square root of 2. But what could I simplify the square root of 8 to be? Times